This video is going to go over functions in real life situations. So we're going to look at some tables and graphs. First of all, we just want to remind ourselves that a function is a relationship between two amounts, an input and an output, and every output or every input has a different output. So every input has a different output. A couple of things that are some examples. If you run, the different amounts of time you spend running, you will always go a different distance. However many hours you work, you get paid a different amount of money. Time spent saving money, you would totally earn more dollars for the different amounts of time you save money. And if you have boxes with items inside them, a different amount of boxes would also always give you a different amount of total objects when you open them and count them up. So we're going to look at two scenarios. The first one says if there are 50 kilometers in 31 miles, write an equation to help determine the number of kilometers in only 1 mile. So if 50 kilometers are 31 miles and I only want 1 mile, I would divide these to know the value of just 1. If I set up a division problem, whoa, I'm still on a super big pen. Let's change that. 50 divided by 31. It's not a perfect number. It goes on forever. So I'm going to round to the hundredths place. It's going to be approximately 1.61. And this is how much we're thinking 1. So 1 kilometer is approximately 1.61 miles. So if I needed an equation, I could put y equals 1.61x, and this is when y is the kilometers and x is the miles. Okay? Now in the table below, they have this flip-flop from what we normally do. Normally x is on the left and y is on the right, but based off of the way we have our equation, we're saying y is our kilometers. So I'm going to relabel this. I'm going to put y over here and x over here. It wants us to try now, if we know this is the relationship between miles and kilometers, figure out how many miles these different quantities of kilometers would be. Okay, so up here, when we knew the kilometers and we needed to get the miles, we would divide. So if I know 3 kilometers, I'm going to turn it into miles. Miles are a longer distance than a kilometer, so all of our miles are going to be smaller. You can see that up here as well. It said 31 miles, and I'm comparing it to 50 kilometers. Miles are always less. So I could add that. The miles are a smaller quantity because the distance of a mile is longer than the distance of a kilometer. So if I come down here and I set up these division problems, 3 divided by 1.61. Again, this is not a perfect number, so I'm going to round it to the hundredths place. It's 1.86 approximately. And if I do the next one, 8 divided by 1.61, it is approximately 4.97. Then 15 divided by 1.61 is about 9.32. I rounded that one up because it the digit after the hundredths place was big enough. Then 20 kilometers divided by 1.61, because it takes that many kilometers to make 1 mile. It's 12.42. And then the last one is 42. So if I do 42 divided by 1.61, it's about 26.09. And I also rounded that one up as well, 26.09. Okay. Then the second scenario we're going to look at is a table, and we're going to pick the graph that matches this information. Which graph represents the relationship between the amount of money earned per hour? Okay, so in our graphs, we know that when 0 is your x And I know hours worked is going to be X because it's on the X axis in my graphs. It's always a good idea just to double check X and then Y. When Y is 0, or when X is 0, then your Y value is your Y-intercept. Whoops. The Y-intercept for this time, it's 0. Okay, when X is 0, the number for Y is your Y-intercept. Then I want to know the slope of the line, or really I'm trying to figure out how much is 1. Remember, if we want to do the slope of the line, that's telling us the constant rate of change, or the value of 1. So this would be my x1 and my y1. This would be x2 and y2. And I just picked these because it's 0. So this number minus 0 is still 22.5. And then 3 minus 0 is still 3. But I'm going to put it down. 22.50 minus 0 is 22.50. And then 3 minus 0 is 3. Then I want to take and divide this so I know how much is 1. If you divide 22.50 by 3, you get 750. So this is the number I'm looking for in my graph. 1 hour needs to match up with 750. If I pull up these two, okay, I come over to where 1 would be at in the graph, and I go straight up till I hit the line. Like, I barely can even go across at all. This middle line right here is 5, then 15 and 25. So that's very, very small, so that's not going to work. If I scoot this graph over and look at the next one, 1 is right here. So if I go up from 1 to the line and go sideways, remember that first spot was a 5. So for this second graph, it is saying that 1 hour equals 5. Okay, and that's not what we want. We want 750. So I can shrink these graphs back down. If I open up the next graph, this one, if I go to where the 1 is, and then I go straight up until I touch the line, and then I go sideways, and between 10 and 20 is 15. So this is telling me that 1 hour equals $15. Okay, that's not what we want either. If I scoot over to this graph and I go to find the 1, I go up until I touch the line, and then I go sideways. That's going in between 5 and 10. So halfway between 5 and 10 is 750. So this would be the graph that I would choose. Our first graph, I'll go back and write on this one because I didn't. I don't know. I'm guessing this one might be 1 hour. Is so small, you would have to make a guess. It looks like 8 hours is $5. And that's less than $1. So I'm going to say less than $1 for that one. But our graph that matched, it looks like underneath that says 750, but that's totally not right here. That did not match up. This one said $5, which is what we got when we did our graph. This one says $15, which is also what we got when we did our graph. And then this one said $750, which is what we did when we got our graph. And so that one would be your correct answer. I'm not sure why the other graph had that amount on it, but it was $750.